Okay, let's talk about the difference or a difference of two squares. Okay, spoiler alert, it is a difference of two squares. So if you notice a pattern where you have a perfect square minus a perfect square, all we're going to do is set it up in the a minus b, a plus b pattern. If you remember last week when we did the shortcuts, this was one of them where I was like, hey, if you have a minus b, a plus b, you can multiply that to a squared minus b squared. So now we're doing the reverse. And if you see something that's a perfect square minus a perfect square, you know, hey, that's going to be the pattern a plus b, a minus b. Because look, outside products, negative 2x, inside products, positive 2x, they cancel, but 2 times negative 2 is negative 4. So perfect square minus perfect square, easy. 2 parentheses, x minus 3, x plus 3. 4x squared minus 25, that is a perfect square minus a perfect square. So 2x plus 5, 2x minus 5. On the next one, we have 4m squared minus 16n squared, perfect square minus perfect square. So we can go ahead and make it 2m plus 4n into m minus 4n. On number 5, perfect square minus perfect square, 6x minus 5y to the third times 6x plus 5y to the third. So why don't you try the last 4 and then we'll check your answers. Okay, 9 is a perfect square. These are perfect squares. 49 is a perfect square. So 3a to the 4th b squared plus 7, 3a to the 4th b squared minus 7. Because look, 3 times 3 is 9, a to the 4th times a to the 4th is a to the 8th, b squared times b squared is b to the 4th. 7 times negative 7 is negative 49. This would give you negative 21 a to the 4th b squared plus 21 a to the 4th b squared, which would cancel. Number 7, you should get 2y plus 7, 2y minus 7. Number 8 would be 4x plus 5y times 4x minus 5y. And then number 9 is a to the third, b to the second plus 2, a cubed b squared minus 2. Okay, so let's talk about if they have a common factor. Okay, we're going to factor that out first. Okay, and there was one actually at number 4 above that had a common factor, but no worries. We'll start factoring those out here. Okay, so what that means is, for example, what we worked on a few days ago is that both of these are divisible by x to the 4th. So that would give you 4 minus 9x squared. So that would be x to the 4th, and then 2 minus 3x, 2 plus 3x. Okay, or on this one, because it doesn't look like a difference of two squares because 18 is not a perfect square. Well, what if I divided it by 2 and then a squared first, because this has an a squared and this has an a to the 6th. So now I have 9b squared minus 25 a to the 4th. So now, is this a difference of two squares? Yes, it is. So 3b plus 5a squared and then 3b minus 5a squared. Okay, and then 32, what's a common factor between both of those? Y to the 6th power. So I can put y to the 6th power, and then that's y squared minus, oh, and you know what? I should not have that. That shouldn't be 9. That should not be 8. Let's make it a 9. So y squared minus 9, and then that factors out to y squared, y to the 6th, and then y minus 3, y plus 3. Okay, and then the last thing we're going to talk about is factoring completely. So I'm looking at this and I'm like, okay, is there any common factor? No. So I'm going to set it up as 9x squared minus 1 times 9x squared plus 1, right? Square root, we're good. But what is this? Is this a perfect square? Is this a perfect square? Yes, so we can actually split this one. We can factor it further into 3x plus 1, 3x minus 1, and then that one didn't change. It stays 9x squared plus 1. So you just want to make sure when you're done that you check your differences to see if they're a difference of two squares. So another example like this one, we would have 4m squared plus n to the fourth times 4m squared minus n to the fourth. Okay, that one's good. This is a difference of two squares again, right? So I'm leaving 4m squared plus n to the fourth alone, but then this one is going to get split into 2m plus n squared and then 2m minus n squared. Is this a difference of two squares? No, because 2m is not a perfect square.